Welcome to DellyMaths Concepts. Today, what we're looking on is solving simple algebraic equations. If you're new to this channel, I'm asking you to subscribe to the channel, like this video, and drop a comment. Let's get into it. All right, so here we have a few examples that we want to be looking at. So in case number one, what we have here is x minus 5 is equal to 9. As you can see, what we want to do is to employ the principles. Because this is a minus 5, what we're going to do is to do the inverse operation to that, which is to add 5 to it, so that a negative 5 and a positive 5 becomes 0. Then we're going to balance the equation by adding 5 to the other side of the equation. What we're left with on the left side is that x is now equal to 9. So what this means, if we should have put 9 here, 9 minus 5 gives us 4. So this is correct. Let's take a look at this. In this case, we have m plus 8 is equal to 11. Because we have a plus 8 here, to get rid of that positive 8, we're going to subtract 8 by doing the inverse. And then whatever we do on one side, we do to the other side, we're going to subtract 8 here as well. So by simplifying this, positive and negative 8 becomes 0. M is equal to 3. Let's take a look at C. We have y minus 3 is equal to 0. The opposite of negative 3 is that we want to be adding 3 to it because we want to get a 0. This is what we call a 0 pair. So if we add 3 to the left side, we need to add 3 to the right side for balancing. Now, negative and positive 3 becomes 0, so y is equal to 3. H plus 2, I'm at D. H plus 2 is equal to 6. We have a positive 2. How do we get rid of a positive 2? We subtract 2. This is the opposite of it, or what we call to do the inverse. So a positive and a negative 2 becomes 0. But because we subtract 2 from the left, we have to subtract 2 from the right side to balance the two sides of the equation. So at this time, H is equal to 4. Right? So those are our first 4 responses. Let's take a trip to more questions. All right, let's take a look at these. Now, in this case, what we have here is 4z, which means 4 times z. How do we get rid of the 4? We do the inverse of what's happening. So because 4 is multiplying to the z, we're going to divide by 4. So we're doing the inverse of multiplication. And whatever you do to one side, you do to the other side. You divide by 4. So as you could see, 4 would have canceled itself. So on the left side, we have z, which is now equal to negative 24 divided by 4. And that's going to give us negative 6. Right? All right. Let's go. This situation here at B, we have h divided by negative 5, which is equal to negative 6. All we have to do is to observe to see what's going on. H is divided by negative 5. So let me rewrite this. So we have h, and it's divided by negative 5, and the result of it is equal to 6. We want to get rid of this negative 5 right there. What is the opposite of negative 5? The inverse of it, right? In other words, not opposite of negative 5. What I meant was, what is the inverse operation to dividing by a negative 5? It means to multiply, right, by negative 5. So you divide, the inverse of it is to multiply. But whatever you do to one side, you have to do it to the other side. So we're going to multiply the right side by negative 5. Now, on the left side, negative 5 cancels itself, and then you're left with h. But on the right side, when you multiply negative 6 times negative 5, we get positive 30. And there you go. Now let's take a look at C. At C, we have negative 6c, which is equal to negative 42. Now, what's going on here is that the negative 6 is multiplying to c. So the inverse of multiplication is the divide. We're going to divide the left side by negative 6 so that the negative 6 cancels itself. For balancing sake, you have to do the same thing to the other side. We're going to divide the right side by the same negative 6. C is equal to positive 7, because negative 42 divided by negative 6 is 7. Let's take a look at D. For D, negative 9 is multiplying to the U. So in order to get rid of it so the U could be by itself, I'm going to divide by negative 9 and balance the equation by dividing the other side by the same negative 9. On the left side, when I divide by negative 9 would have canceled itself. I'm left with U. This is going to equal to 45 divided by negative 9 is negative 5. We're solving simple equations. Let's take a look on our last 4 examples. So for this one, we're looking at a 2-step process. There are multiple ways to do it, but one of the easier ways, I would think, we're going to save anything directly attached to the unknown for last. So it means then I'm going to leave this for last. When I'm working with it, I'm going to leave that for last, leave that for last, leave this for last. So let us attack them. So in situation A, we have 7x minus 4 equal 10. My intention is that I need to get rid of that negative 4 by adding 4 to it, so that a negative 4 and a positive 4 would have been canceled out fully. Whatever I do to one side, I have to do it to the other side. So I have to add 4 to the right side. Let us simplify. We're looking at 7x, which is equal to 14. Now, 7 is multiplying to x, so I'm going to have to divide. So this is the inverse operation. But whatever you do to one side, you do it to the other side. You divide by 7 as well. Let us simplify. 7 cancel 7. So I'm left with x on the left side. 14 divided by 7, that is 2. What this is suggesting that if I should substitute 2 here, 7 2 is 14 minus 4 is 10. Right? Let's take a look at the B. Is a similar case. I have 7k plus 2 is equal to 16. The intention is that I'm going to get rid of this positive 2 by subtracting 2, balancing the equation by subtracting 2 from the other side. Then I'm going to rewrite what I have. So this 2 subtract 2 is gone. So I'm left with 7k. 16 minus 2 here is equal to 14. Then I'm going to divide by 7. So as you could see, k is equal to 2. Now let's take a look at C. In this case, I have multiple ways to do it, but what I'm going to do is I'm going to remove the 7. So I'm going to write back my negative b, right? But in this case, I'm going to get rid of the 7, right? So remember, I would have subtracted 7 from both sides here. So 7 subtract 7 is gone. And then this is equal to a negative 7 here. So here is the deal. Basically, what we have here is negative b is equal to negative 7. We could change things up by multiplying everything by negative 1. So I have p equal to 7. Or I could just change the signs, because negative b is equal to negative 7. Positive b is equal to positive 7. So that's what we have right here. Let's take a look at D and the last one. I'm going to get rid of this 33. So what I'm going to do is I'm going to add 33 to both sides. So now that I've done that, I'm going to rewrite negative 12g. The positive and negative 33 cancel, and I'm left with 33 here. Then I'm going to divide both sides by negative 12. Since the negative 12 is multiplying to the g, so if I cancel negative 12 over here, I'm going to be left with g is equal to. So when you take a look at this, I could reduce this if I want. I have 33 over negative 12, but I could break this down by dividing by 3. So 3 into this is 11, and 3 into this is 4. So what I'm actually looking at is that I have. So g is actually 11 over negative 4, or you could have written this as 11, negative 11 fourths if you want. Right? There it is.